this is problem 92 of Neetcode 150 word ladder. So we're going to be given two words, begin words and end words. And we're also going to receive a list of words called word list. We are sure that all the words are in lowercase English and they're all of the same length. And the idea is to transform the begin words into the end words by basically changing one letters of begin words, but only one each round. So what is the minimum number of round that we can that we need basically to reach the end words? So if we take a look at this example, we see that the begin word is cat, and by the way, the begin word is not going to be initially in the word list. The end word is sag, and the end word is in the word list. So what we can see from here is that with cat, we can change cat to bat. And is that the only thing we can do? Well, yeah, pretty much. So from bat, we can do bag, right? By changing the T to a G, and from bag, we can go to sag, which is the word. So that means that we have to render all the words that are implied in this list of change, starting from the begin words. So begin words count for 1, and bag counts for bat counts for 2, bag counts for 3. Finally, the end word sag counts for 4. So let's take a look at this example. We have say, and our list of words contains hey, ray, may, and rat. So a couple words we can do from say, like what we need, what we can do from say, like we can have whatever the first value is, ai, ay, we can have s every value with the y, and we can have sa along with any value. So this is basically everything that is valid. So let me just say can have. So with this can have, let's see all the words we can do. So can we do hey? Not yet. Can we do ray? Yes, we can do ray. Can we do may? Yes, we can do may. And can we do rat yet? No, we can't. Okay, because I didn't specify it, but let's see that our end words is rat. So how do we get to rats with say? So now we know that we can keep going. So we can keep building with ray and may. So we know that we can actually have everything with ay for ray. Let me just put this here so we don't have the ray and the may, which is not better. Let me put this here. Okay, so for ray we can have, well, for ray and may we can have pretty much every value with ay. For ray specifically, we can have r every values y, and for may we can have m every values in y. And now for ray we can also have a with any values, and for may we can have ma with any values. So now we have another can have, and notice that this is another round, right? So we have our first round where we have our may or say, then we have either ray or may, because eventually we're gonna have to pick the word that leads to the shortest path, which will be found by using a breadth first search function, pardon me. So let's keep going. Now we have all these possible values. What can we do? Can we actually do rat? Yeah, we can do rat. So at this point we can actually render the first we can render rat, which will require the use of the word array as the middleman. But we can actually do all the values. So on each round we have a which could be a problem here because we're we're eventually going to call back May and Ray again and say as well. So we're going to have to keep track of a scene list. So all the words that we've seen are going to be put inside our list um, that we define as scene, right? So we want to ensure that if a word is not in this list, so we can scratch this away. Well, from what is left, what can we build? Can we build hey from these? No, we can't. But can we build a rat? Yeah, we can build a rat. So we're gonna say rat, and now we're gonna check if the word that we just built is actually the n word, and if it is, we are gonna return it. We're gonna return its path. So we're gonna say ray and finally rat. But actually in the problem we have to return the length. So what is the length here? It's gonna be 3, right? So I have say I have ray and I have rat. There we go. So that's gonna be the output. So for every round, we're gonna have to increment a variable that will be an integer by 1. Okay, so let's go ahead and code this. And you will see by working through the code, it will make sense. So first of all, the end word should always be in the word list. If the end word is not in the word list, we have a problem. So we're gonna return through. We're gonna return 0 because if the end word is not in the word list, we don't have a sequence. So if we don't have a sequence, we return 0, right? So if end word not in word list, we return 0. All right. With that being said, what I will do next is basically that I will create a dictionary, and for every single words, I will create all the possible options. So for example, the can have will be a key, okay? And for each key, I will have its word. So I will do so by first creating, I will say a default dict. So now it's going to be basically default dict, and it's going to contain lists. The values will be lists. And okay, now what I will do is that for every single word in the word list, I will create their can have value, and I will put this as a key inside this collection, so that after this, um, while we use breadth first search, we're gonna have a DQ, and inside our DQ, every time we're gonna pop a value, we can see the can have of this value, and if this can have is inside scene, well, we can continue. If it is not in scene, well, first we're gonna add this value inside the DQ and inside our set of visited values. And this is gonna help us because we're gonna have basically a dictionary of all the possible can have values of all the words starting from the beginning. So this is what we're creating right now. And notice that the beginning word is actually not in the word list. So I will just say word list dot append, and I will add the beginning word. Okay, so now we can actually create the code for all the can have values of each word. So what I will do is that I will basically have my for loop, and check this out. So for I in the range of the length of the word, all the words are of the same length, by the way. I will make this can have, and I will first take the first part of the word. So word starting from I. Initially, we're gonna cut it at 0, meaning that we're gonna add a star at 0. And after this, I need to take the rest of the word. So I plus 1, and then the colon. All right. And now inside our default dict name, which stands for neighbor, I will add the key can have. And it is a list, so I will append to its value the word. All right, so now we created our dictionary with all the can have values of every single word. So we are good to go to start our def first search function. To create our def first search function, we want to create a scene set. So this is going to be a set which will initially all the begin word, because we start with it, so we know we saw it. We're going to mark it as seen from the beginning. And we want to create a DQ, which is basically the core of a breadth first search function. So inside it, I will also add my begin word. And I will set the res, which stands for results, to 1 initially, because we know that the output value is basically the sequence of the words that we have that we need to go to the end words. And this sequence needs to include a begin word. So when we start from the begin words, we know we already have one word in this sequence. Even if the begin word is equal to the end word, we're going to have a result or an output of 1. So now we can have our while loop while there is a DQ. And we're going to go see all the current value inside of DQ. So I will say what for I in the range of the length of the current queue. So we're going to go see all the values inside. And the word's going to be the value we pop from the left. So q it's so word is q dot pop left. And it is possible that the word that we found is actually equal to the in word. So if it is the case, we want to return the results at this current state. So if the word is equal to and word, this is where I want to return the result right away. Okay. And after this, if we didn't return a result, it means that we just have another word that is not the one that we're looking for. So what I will do is that I will found all its can have values, and I will check basically all the I will check all the words basically that can be created with this can have. So I will need once again to create my for loop to create these can have. So I will say for G in the range of the length of the word, all the words are of the same length. I will create my can have. And my can have, it's the same thing as what we wrote earlier on. It's initially going to take everything starting from the first index like this. And we're going to add to this basically a star. And we're going to add the rest of the word to it. So I plus 1. Okay. So now we have all the can have for the first word that we popped out of the DQ. And I will basically say for an in neighbor. And we want to get basically all the words that can be formed from this can have that we have. So for all these words, well, I want to check if it is invisited. We are going to do this just like that. So if the word hasn't been seen yet, which is quite important, because If, for example, you have the word may and the word say in your word list, well, from the word may, you can create the word say, but from the word say, you can also create the word may. So if you don't somehow keep track of the words you've already seen, you're gonna have an infinite loop. So we have to ensure that we only go see this word inside our breadth first search if it has not been seen yet. So if n is not been seen, well, we can with confidence add it to seen, and we can also add it to the dq. So q dot append n, and that's it. So for that's it for this round. Once it is done, we're going to increment results by 1, right? So this is one round of basically all the, like, starting from words, we're going to go see all the words that can be created from these initial words. And now for all these initial words, we're going to go see all the words that can be created from each of them. So that's breadth for search. And after each round, we're going to increment the result by 1. And if we never return a result here, and we break the loop, it must mean that there's basically no pathway from the begin word to the end word, in which case we're going to return a 0 as mentioned in the problem. So there we go. That's the solution for this problem. I hope you learned from this video, and I hope to see you in the next one.